so we have it. Okay, so I was talking about disproportionate versus proportion stratified random sampling. And then I was answering your question as to why you would want it disproportionate versus proportion. Did all of that come through?
Yeah.
It did. Did it make sense?
Yeah.
Okay, super. Well, best of both worlds. Keep at it. All right, so sampling distributions just at large. When you are doing a sampling distribution, it's really a theoretical distribution of all possible sample values for the statistics that we're interested in, right? So we're taking a snapshot, a smaller sample of a greater population, and then making sure that we're doing the best that we can to have it be representative of the population at large. A sampling error is the discrepancy between a sample estimate of a population parameter and then the real population parameter. So it is important to know that whenever you do a sample, the goal is to have the numbers you get from it generalize, right, to the overall population. But it's not always going to be 100%, right? You're not going to hit it right on the nose where your sample 100% mimics the population, which means you're going to have some sort of sampling error. That is totally normal and to be expected. The only way you have no sampling error is by not doing a sample and then you're doing a population. So that discrepancy between your sample estimate and the actual population parameter, that is what's called sampling error. Okay, so you can see here, this is the personal income for 20 individuals. That's totally hypothetical, data here. So you see the 20 people and then their income, right? And then the mean is 22,766 and the standard deviation is 14,687. Now, for it to be a really good sample, those results should come very close to the population parameter, right? The mean income for the population, right? Is it going to be right on the nose? No. Now I want to make sure I didn't lose you guys again.
No, we're all good.
Feeling distrustful of my internet. Okay, so if I look at it, I can see here, if I look through and I specifically choose a subset of each and calculate the mean for them, then I can see if it mimics again. So this is a very tedious process, but I would take 3 random cases at a time and calculate their mean to see if they're close to one another, okay? So you would be repeating this process 48 more times until you have 50 samples of an N of 3. Just, no problem. Just quick and dirty. So out of these groupings, right, the mean of those 50, you can see the total, you would have the mean of means is 24,749. So that is the way you do it. You take all of your samples and then do the distribution between these each, right? You're sampling, resampling within, and do the mean of means to see how much it approximates it. Okay. When you are doing a sampling distribution of the mean, again, you've got your theoretical probability as to where it's going to be. That would be, if you're randomly drawing from the population of all possible samples within that. So, for instance, if I looked at the distribution of grade levels among 90,000 school children, again, this is fake, I would say that for those 9th grade, randomly, there's 10,000 for each grade, right? Kind of a random distribution of that. Here, why is this tiny? Here we go. Now, on the other side, if this is a distribution of the means of 3 randomly taken samples of 2 school children's grade levels, each from a population of grade levels of 90,000, right? Then you do the mean of means and standard deviation and variance within each. I'm getting real granular here, which big picture, right? When you are sampling, you are taking a shot at what's going to look like within your general population. It's not going to be perfect. This is what I'm trying to highlight with all of this. Okay. So If you're generating the sampling distribution of the mean, you would have to do this. This is from a population. You start drawing samples from that population and you get the means of each of those samples. So this is to highlight, this mean represents the average of means right here, okay? This one is this one. And then as you go through, it should mirror a normal distribution. That's the whole point, right? We know that most populations and most samples are not going to be a perfect normal distribution. But if I do enough sampling, it's going to approximate a normal distribution. Okay, so same thing. So these are histograms of means. Again, this is means of 2 grade levels that are randomly selected, just like I was talking about earlier. So these are shown for 50 of the means, or you can see here 200, 400, 600, 800, and 1,000. What do you guys notice about these histograms? What do you think?
I noticed that the second one, 200, is a little bit of a, like, doesn't follow the trend of the rest.
Mm-hmm.
After it reaches 405 becomes everything.
Mm-hmm. Right, so when you look at this here, maybe some of the differences are highlighted a little bit differently down here. But so the major trend here is the greater the sample, the more it looks like a normal curve, right?
Yes.
Okay, so first, if you just have 50 means, it's pretty flat and low, right? But as you get, again, more means that you're averaging throughout, it's going to start behaving more like a normal curve, like a normal distribution would. Okay. So again, theoretically, what you're doing is the distribution of means are based on very large number of samples that have the same size. So within each, it's all the same sample size, but you're doing means of large quantities of samples. So the greater you're going to approximate the overall population mean is what that means. Move that away. Okay, so some characteristics as to the distribution of the means. The shape is going to approximate the normal curve if the sample includes 50 or more individuals and if the distribution of the population of individuals is actually normal. If within the population you have a normal curve that exists or a normal distribution, that should also be mirrored in the distribution of means, okay? So this is just a quick summary of the rules to determine the characteristics, again, of that distribution of means. The mean is the same as the mean of the population for individuals. Variance is the variance of population. The shape of the distribution is going to be approximately normal if you have more than 30, and the shape of the distribution is approximately normal if you have 50 or more, regardless of whether the population is normal or not. Just some key factors right there to keep in mind. Okay, so how do we go about comparing the distributions within population of individuals and the distribution of means? So up top, right here, you have the distribution of population. So this is, let's say, the distribution of height of men in America, right? This would be your distribution, whereas, I don't know, what are we thinking is the mean height for men?
5'9", 5'10".
Yeah, so let's do with 5'9". So you're gonna have some that are much shorter and very few that are much taller, especially here in the state of Michigan. Now, when you do a distribution of means, is you take multiple samples, let's say at least 50 samples of men, right? Where you calculate how tall they are. Now, each of them might look exactly like this, but once I do the mean, the distribution of means, notice what happens to the normal curve. What do you notice?
It gets all skinny.
It gets skinny. And why is that? Do you guys remember, like the flatter it gets or the skinnier it gets, what does that represent? It's how much it varies, right? So if I am looking at test scores, right, on an exam, and almost everybody scored, let's say 95% of my population, my students in my class, scored between an 87 and a 91. That's a very short spot, right? So then you get nothing, 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 and whoop, it bleeps right up, right? So it's very skinny. There's less variance. Versus, I think we talked about this a couple class sessions ago, the class where there's a few A's, but several F's. That's a much flatter, wider curve because there is more variance. There's more variability within your sample. Okay. So when you're looking at a distribution of means, they're all going to be fairly similar, right? Because if each sample, let's say of 50 people as to the height of men, their means are going to be close to that 5'9" that we estimated at the beginning, right? If we think 5'9" is going to be right here in the middle, most of these means are going to be right around 5'9". Does that kind of make sense? So that is the behavior of the curve. Now let's just remember real quickly, this could be the distribution of the population of individuals. This here is the particular sample, and here's your distribution of means. Okay, so that's one sample, right? Not as smooth as a normal curve, and that's the distribution of means from multiple samples trying to approximate the population. Okay. Sampling distribution, specifically with standard error of the mean. So whenever we look again with any sample, there's going to be some level of error within it, right? Because it's never going to be perfectly identical to the population. What we need to figure out is how much does it vary? So by calculating the standard error of the mean. So first, you need to figure out what is the standard deviation of the sampling distribution. You need to describe how much it is dispersed or different, and if there's a sampling distribution of the mean in it, and how much of our sample is in the error of the actual population mean. So to do that, you would need to know your population standard deviation divided by the square root of your total population, okay? So this would be one way to calculate it in regards to income, right? We were doing that earlier, which then shows you that your standard error is right around that. You are not going to need to know how to calculate the standard error of the mean. So this is just for your own edification if you're like, let's learn more about stats. What you do need to know is that every time you're doing a sample, it's going to approximate your population. And within that, there's always going to be some amount of error, right? Some deviation or distance or change from the population, because we can only do so much in approximating the population. Okay, questions about that? Did I get everyone super confused now?
No, super clear.
Okay. Insert sarcasm? I don't know. Okay, well.
A minute to digest everything.
Okay. Well, the last part of today's lecture is in regards to the central limit theorem, which we've discussed in the past, maybe not using those exact words, but the idea is that of all possible random samples of size n are drawn from a population with a given mean and a given standard deviation. As n becomes larger, the sampling distribution of the sample mean becomes approximately normal, with the mean of that sample approaching that mean of the population, and same with the standard deviation. Okay, what does that mean? If I know that in the United States, most families have 2.4 children, right? If I take samples of families and those samples are large, okay, and I take random samples in all parts of the United States, as I look through each of those samples, the larger my N, meaning the larger my sample, the more closely it's going to line up with the actual population data, the population parameters. Okay? So with a sufficient sample size, the sampling distribution of the mean will be normal regardless of the shape of the population distribution. Okay, so even in a case where I'm measuring something within my population that may not be normal, with greater sample size, I'm going to approximate a normal distribution. Okay, so let's talk about that a little bit more. This is just repeating what I just said. So as the sample size gets larger, the mean of the sampling distribution becomes equal to the population mean. And as the sample size gets larger, the standard error of the mean decreases in size. Okay? I'm making fewer errors as I'm approximating the general population. Okay, so here's 3 income distributions, as can be seen here. This is the population distribution of personal income for 20 individuals. Here they are written, okay, what their income is. This is a sampling distribution of the sample means. Again, this is taken an N of 3. So I take 3 of those in here, keep evening it out. This is what we were doing earlier, okay? This is already looking a lot more like a normal distribution, okay? And now this is sampling distribution of sample mean for a sample of N equals 6, okay? So this is even more so than that. We noticing more normal, okay? And this is a last parting reminder. This was the last note on central limit theorem. Looks more normal. This is notations. The difference between population and sample and how you notate it. This is what it looks like. And this is how you would note the sampling distribution of the mean. So major takeaways from today's class that you guys need to make sure that you study for. You need to know how to do, what does it mean to take a sample? You need to know what is a simple, where is my simple random sample? Right here, simple random sample. What is a systematic random sample? And what is a stratified random sample? Within that, know what's disproportionate and proportionate. You need to know what's the difference between a parameter and a statistic, right? For samples and population. And then have a general idea as to what is the central limit theorem. What does it mean? Okay. Questions, comments, concerns? Everybody's good?
I'm good on my end.
I was just gonna ask, I don't know how much you would be willing to discuss this, but how would you suggest the best way to review the exam would be?
Okay. The best way to review the exam.
Okay. For the exam.
Yeah, where did you guys just go? Can you guys still see me?
Yep.
Or am I sharing my screen? Okay. So let me pull up a few things here. So first step is there's going to be a section, as I mentioned, that's going to be more lab-based, so that I'll be giving you guys Excel spreadsheet where you'll need to do some data analysis. I'm only going to ask you things that we've done in this class before, so review those things, right? So the labs, review how to get a mean, standard deviation, review how we ended up getting those, remember we did all of the tables to figure out the standard deviation, know how to do that from both of the labs, okay? So that's a big takeaway. Aside from that, you need to know, back from the quizzes, the major things that we talked about in the quizzes. So what are variables? Like independent versus dependent variable. what is a mean, median, and mode, right? We talked about at the start of class. What are the different types of variables, like a nominal variable, ordinal? That should all ring a bell, right? So review that. Review the different ways that you can visualize data. We talked about that. I think that was on one of the quizzes too. You had to make a pie chart. But remember, there's other types of visualization you can use, like a histogram or a bar graph. What do those look like? What's the benefit in each of those? I mean, obviously, everything we talked about today in terms of sampling, the different types of sampling, some benefits or shortfalls. More broadly, what does it mean to have a mean? What does it mean to have a standard deviation? What's the benefit of standardizing it through a z-score? I'm throwing a lot at you right now, but just those would be some generalities of things you'd need to know. Does that help, Greg? I think it was Greg who asked.
Yeah, no, that's perfect. Thank you.
Okay. Daniel, did you have a question too? Because you unmuted yourself right around the same time. If you're speaking, I don't think I can hear you.
I'm good.
Oh, you're good. Okay.
Okay. Good.
Any other questions? Okay. Take this next week to review all this material, review the lectures. They're all on YouTube. Please do reach out if you have any specific questions. Feel free to always text me or email me, and I'll be happy to assist you in any way I can. I'll make sure that both of these lectures are on our class YouTube page within the next 20 minutes. This way you guys can review that too.
Thank you so much.
No problem. All right. Well, yes?
No, thank you.
Oh, no problem. Okay. You guys have a great rest of your day, and let's talk soon.
You too.
Feel better.
Bye. Oh, thank you.